When you're given a word problem involving quadratics, it's kind of hard to know sometimes what you're supposed to do. So there's two main types of problems that we will see. The first type that we can see would be ones that have the keyword of maximum or minimum in them. If the problem's asking about a maximum or minimum, you have to use the vertex. So when you think about what the vertex is, right, is the highest or the lowest point on your graph. So when they're talking about maximum or minimum, we're dealing with the vertex. Questions that would include that would be something like, when does it reach the maximum height? Or what is the maximum height? Or what amount gives the highest profit? What is the highest profit? The second type of problem that we see are the projectile, trajectory, and like zero type of questions. In those cases where you don't see the keyword of maximum or minimum, you're going to use factoring or the quadratic formula. So questions like that will include, when will the football hit the ground? When will the population be extinct? When will the ball reach a height of a certain amount of feet? Okay, so if we look at this first example, we have a golf ball is hit from the ground. So if we think about what this is, we have a golf ball, and it's hit from the ground, and it makes this parabolic path. If we think about this as being an XY plane, we have the x's, in this case they're t's, and it tells us that t represents the time in seconds. So this is t for time, and this is in seconds. And the h of t is the height, and the height is in feet. And we want to find the maximum height of the ball and when will it attain this height. So what we're really doing is we're finding the vertex. So the key word here is that it's asking for the maximum height. If you think about this ball being hit, the maximum height, when you have this xy point for the vertex, the y would be the maximum height, and the x would be the amount of seconds to reach that height. So all we need to do is to find our vertex. So we're going to do x equals negative b over 2a. Now with word problems, it's okay to have decimals. Okay, you want decimals with word problems, so it actually makes sense. We're going to have 2 times negative 16. So when we plug this in, we get negative 180 over negative 32. So x equals 5.625. And then we're going to find the y value of the vertex. So we do y equals, and we're going to plug in the 5.625 in for x. And then we end up with y equals 506.25. So now we have the x and y of our vertex. So if we think about it in vertex notation here, we have 5.625, comma 506.25. So now we have to actually answer the question. So what is the maximum height of the ball? Well, remember the height, if we look at our little diagram, the height is the y. So we would say that our maximum height is 506.25 feet. Okay, we want to make sure that we label it. So if it's a word problem, we should have the correct label. And then when will it attain this height? So time to reach height would be the x value or the t value, and that would be 5.625 seconds. Okay, now looking at this example, okay, you have a rocket carrying fireworks being launched from a hill 80 feet above a lake. Okay, the rocket will fall into the lake after exploding at its maximum height. The rocket's height is given by this function. So even though we have the word maximum, it's not part of our question. It's part of the setup. So it's saying that at some point it reaches maximum height and then it starts to fall back down. So the question for part A, how long does it take for the rocket to reach a height of 140 feet? So since it's not asking us what is the maximum or how long it takes to get to the maximum, this is going to be where we're going to either try to factor or use the quadratic formula. So it has a height of 140 feet. So that means that the h of t, we're going to replace that with 140. So we're going to set this up as 140 equals negative 16t squared plus 64t plus 80. Now remember, before we can factor or use the quadratic formula, we need this to be set equal to 0. So you have to move the 140, subtract it, and bring it over to the other side. So we end up with negative 16t squared plus 64t minus 60 equals 0. So from here, you can try to factor it. You would pull out a GCF and then try to factor from there. Or if you're not great at factoring or you don't want to try to think about what multiplies to what, you can use your quadratic formula. So I'm just going to plug it into the quadratic formula quickly here. So negative b plus or minus. So if I do b squared minus 4ac, that's going to give me 256 over negative 32. Now 256 is a perfect square, so that means that we could have factored this. And with word problems, we said it's okay to use decimals, so you can just plug this right in the calculator. And remember, you're going to have two answers. So you have the negative 64 plus the square root of 256 over negative 32, and then we're going to do negative 64 minus the square root of 256 over negative 32. So when we do this, we get two answers. We get that t equals 1.5, and we get that t equals 2.5. So what this means is that at 1.5 seconds, and then again at 2.5 seconds, this rocket is going to be at 140 feet. So when we think about the graph of this, it goes up and it comes down. So let's say this is 140, where I'm putting these dots. It's hitting it twice, but the question is asking how long does it take for it to reach that height? So out of the two answers, which one is going to make sense? So in this case, the 1.5 makes sense because that's the first time it's going to reach 140 feet. So we want to make sure we label it as seconds, and that's going to be the one that we use as our answer. Okay, so even though at 2.5 seconds, it's going to be at 140 again, it's not the first time that it was. So with word problems like this, you want to pay attention to what they're asking, like if they're asking for the lowest amount or the highest amount or something like that. So when you get two answers that they both could make sense, you need to think about which of those two answers is actually the one they're looking for. Okay, so in this last one, after how many seconds after it is launched will the rocket hit the lake? So if the rocket's hitting the lake, the height of the rocket will be at 0. So when it hits the lake, it's at 0. So we're going to take the function and we're going to set it equal to 0 because that's what the height is. So height is 0, so equals 0. Okay, so again, you can try to factor it. You can plug it into the quadratic formula. Again, I'm just going to use quadratic formula real fast. So negative 64 plus or minus the square root. If I do b squared minus 4ac, I get 9,216 over negative 32. And again, this is a perfect square, so if we were to factor it, it would have worked. Plug it in the calculator twice. So negative 64 plus the square root over negative 32, and negative 64 minus the square root. So you're going to get two different answers. So t is going to equal negative 1, and t is going to equal 5. So we have two answers. Go back to the question, see what it's asking. So after how many seconds after it is launched will a rocket hit the lake? So this is time in seconds. So negative 1 seconds or 5 seconds. So which of these doesn't make sense? Obviously negative 1 doesn't make sense, right? We can't have negative time. So we're going to ignore that answer, and 5 seconds is going to be our answer. So it's going to hit the ground in 5 seconds.